So, hi dear students. So, this is Dr. Vijaya Babu. So, in the previous lecture, I think we were discussing about the basic concepts of voltage division, current division, KVL, KCL, and finally, I think we have done with delta to star and the star to delta conversions. Okay, so upon all these concepts, always will try to help us to analyze the network, right? So whenever a network is given, sometimes a node voltage being asked, or the branch current being asked, or else the voltage drop across the resistor being asked, so or else any current through the resistor being asked, so or else the power drop across the resistor being asked. So usually these are the questions usually, so you'll try to get in the network analysis concepts. So most of the times the basics such as applying KCL, applying KVL, okay, or else applying voltage division or applying current division, or else finally you can choose star to delta and star to delta and delta to star conversions. Okay, so to solve the concepts of network analysis. But sometimes, okay, you will be having some ambiguity, so or else you will be having some doubt. Okay, so whether to apply voltage division or whether to apply current division, or else which one to be chosen, which method to be chosen, or else don't we have any proper procedure, okay, so to apply on the network, so that you will be getting the unknown constants or whatever the being asked. Okay, so directly you can get that, so without applying all of these, that means we don't know sometimes whether voltage division can be applied or sometimes current division can be applied. Sometimes all these basic procedures are not possible to solve the problem. Okay, so there is some ambiguity in some complex questions. So in having or keeping in mind that, so to solve those complex questions, or else you can solve the basic questions too, so you can solve any question, I can say simply. So you can, there is a systematic procedure in network analysis, so you can apply two important methods in this context. Usually the two important methods are nodal analysis and the mesh analysis, right? So these two are the very important systematic procedures that can be applied to any network. Okay, so if you have an ambiguity in applying those basic methods what I taught previously, so in this network analysis problems, okay, so there is systematic procedure. Systematic procedure means it is very clear that any network is given, so you can follow grantedly the systematic procedure of nodal analysis and mesh analysis, and you get the solution what you want finally. So that is why, so always this nodal and mesh analysis are always on the greater demand, okay, in applying the network analysis problems, right? So we'll try to go ahead with first of all the nodal analysis. So before going ahead with the nodal analysis problems, so it is very important to understand the procedure that should be followed compulsory. Anyone who is applying this nodal analysis to the any problem of networks, okay, so compulsory everyone must follow the same procedure, unique procedure to apply the nodal analysis, right? So that is why first we'll start this session with the procedure of nodal analysis, or else how to apply nodal analysis for a given problem. So we'll try to go ahead with that. So the first step, we'll try to go ahead with the procedure of nodal analysis. So I think in the previous lectures I was able to tell you, right? So what is meant by a node, what is meant by a mesh. So I think all those things, I think in the previous lectures you can see them, the definitions and how to identify them in a network. So already we have done that. Now we are going ahead for the procedure of the nodal analysis. The first important point what to be taken is you need to identify the number of nodes in a network. Okay, so identify the number of nodes in a network. So however I will try to show you how to identify this when once I took the problem, right? No need to be no, need not to be worry about this. So identify the number of nodes in a network. So next one, so consider one node among them, okay, as ground node and taking its potential at 0 volts. Okay, so you can consider the potential of this is at 0 volts. So how many remaining nodes? One node is ground node, means total are n, so remaining is n minus 1. So assign nodal voltages as V1, V2, V3 and so on V n minus 1. Okay, assign nodal voltages as V1, V2, V3 and so on V n minus 1 for all remaining n minus 1 nodes. Okay, for all remaining n minus 1 nodes, try to assign the nodal voltages V1, V2, V3 and so on Vn minus 1. That means let us assume 4 nodes are there in the circuit, one node must be grounded and all the other 3 nodes are V1, V2 and V3. So coming to the, once you have assigned the nodal voltages, now what you need to consider is you try to fix the branch currents. Okay, so it is very important. You need to fix the branch currents immediately, right? So nodal voltages you have assigned, then you need to fix the branch currents because we are going to apply KCL at the nodes now. So to apply KCL, compulsory you must have currents in the branches, right? So that is why you can fix the branch currents in the network. So once you fix the branch current at the in the network, okay, so apply KCL at each and every n minus 1 non reference nodes. Usually this ground node we call it as reference node. Okay, in the same way, all the remaining V1, V2, V3 and so on Vn we call it as what? Non reference nodes. So you will try to apply KCL at each and every non reference node. Okay, and finally, so very important, you need to solve the, or I can say you can solve the KCL equations better now. So the you can solve the KCL equations, okay, to get the nodal voltages, to get the nodal voltages. So anyone who is trying to apply the nodal analysis procedure, okay, so on any given network, compulsory everyone should follow strictly all these 5 important points. Okay, so now we'll try to go ahead to solve the problem, but before going ahead to solve the problem, okay, so every time along with KCL, okay, we take the help of Ohm's law as well, okay, to calculate the or to represent the branch currents in terms of nodal voltages. Very important point is the branch currents are represented in terms of nodal voltages. So the branch currents are represented in terms of nodal voltages using Ohm's law. So usually, so most of the students will try to do the mistake in this concept, that is applying the branch currents representation in terms of nodal voltages using Ohm's law. Okay, so that is why. So going ahead with the problems, so we'll try to see some of the basics, or else how to apply the Ohm's law if at all the nodal voltage is given. So how to calculate the branch currents. We'll try to see some basic logics on this. Then after that, so we'll try to go ahead in solving the concepts of network analysis using nodal analysis. So right, so going ahead, so that is why usually we say, actually, the nodal analysis, I can simply say that it is nothing but application of KCL plus Ohm's law. So this is very very important observation actually. So need to be followed. So the nodal analysis always what? You need to apply KCL at the node. Also you need to apply the Ohm's law. Okay. So to get the current. So however, application of this Ohm's law, we will try to go ahead now. So let us consider a small circuit. The a logics are given. A resistor is given something like this. A resistor is given something like this. A resistor is given something like this. A resistor and a voltage source is given something like this. A resistor, a voltage source is given something like this. Okay, similarly, a resistor, a current source, something given like this. Also, so I have given with the resistor values 2 ohm. So 2 ohm, let us take all the similar values, need not to be worry about them. Okay, so this take it as 10 volts, so take it as 5 volts. Okay, also indicate the nodal voltages. So let us consider all these are the nodes and the nodal voltages. So let us assume the nodal voltage of this one here, it has 4 volts, it has 2 volts. Okay, so take it as 8 volts, take it as 3 volts, 4 volts, 0 volts. Anything you can take roughly. It's not that much important, but the logic is very important. So how you are applying the things. Okay. So and this take it as 4 volts, take it as 2 volts, the nodal voltages. So here as 20 volts, so here as something 7 volts. Okay. So take it as current source is there na. So take it as something 4 amperes, and this has something 10 volts and 5 ohms, 5 volts. Okay, so now I will try to show our target. So our target is to calculate I1 here, I2 here, I3 here, I4 here, I5 here, I6 here. So our target is to calculate what? I1 is equal to, I2 equal to, I3 equal to, I4 equal to, I5 equal to, I6 equal to how much? So this is our target, right? So how will you calculate the value of I1? So I1, whenever you are applying the Ohm's law, always you need to take the resistor, and for that resistor you need to consider, so the direction of the flow of current, wherever the current is starting, take it as high potential, and the current is ending, that you can consider it as a low potential. So that means here I1 is always is exactly equal to 4 minus 2. Okay, and then divided by the resistor value. So resistor value is 2, so answer is 2 by 2. So answer is, it is 1 ampere. Okay, so this is how you need to apply what? Ohm's law. So how I have applied the Ohm's law? I is equal to V by R, or else you can say VAB. So VAB is the potential difference between A and B, that is 4 minus 2 will be the difference. VAB 4 minus 2, that is 2 by 2, so 1 ampere. So in the same way, the value of I2, I'm going ahead. So value of I2 is equal to 8 minus 3 divided by 2. 8 minus 3 divided by 2, right? That means almost 5 by 2, 2.5 ampere. So this is how you need to apply the Ohm's law. Similarly, I3 is equal to 4 minus 0 divided by 2. So 4 by 2, 2 ampere. So this is how you need to apply the Ohm's law. Now lastly, the value of I4 is equal to here. So you should be very clear, okay, that so how to apply So I'll try to show you with the maroon color. See here. So this is 10 volts. Descent voltage is very important to calculate I4. Okay. So what is descent voltage? Descent voltage, is it 5? No. Descent voltage always with respect to ground you need to consider. So that means descent voltage, here to here you have a 5 drop, and then here to here you have a 2 drop. That means the potential at this point is now how much? 7 volts. So now the value of I4 is how much now? So this is also with respect to ground only. This 10 volts is also with respect to ground. All potentials are measured with respect to ground actually. Okay. So that means I4 is now what? 10 minus 7 divided by resistor value 2. So that means 3 by 2, 1.5 amperes. So this is how you need to apply the concept, right? So similarly, the value of I5 you can easily calculate. So the value of I5 is nothing but 20 1 and voltage. What is this voltage with respect to ground? With respect to ground, you have 10. Along with this, you have from here to here you have 10, and then you have what? 7. Okay, so total is, this is something like 20 minus, okay, 10 plus 7 divided by how much? The resistor value is 2. So this is 20 minus 17 divided by 2. That means once again it is 3 by 2. So answer is 1.5 amperes. Right. So finally this logic I6 here, it is not required to apply any Ohm's law because directly you have connected the 4 ampere source. So strictly, so whatever the effect in the circuit you have, this branch current is always fixed to 4 amperes. Need not to be worried about the potential at the ends, and also need not to be apply the Ohm's law. Okay, so only the important logic here is what? So just you try to go ahead, because the current source 4 amperes is there, so in that branch whatever will happen, the current in that branch is always fixed to 4 amperes. Okay, so now I'll try to copy all these values now. So I1 is 1 ampere, I2 is 2.5 ampere, and I3 is 2 ampere, and I4 is 1.5 ampere, and then I5 is 1.5 ampere, and then I6 is 4 amperes. Okay, so this is how you can apply the logic of Ohm's law to get the branch currents if at all the nodal voltages are known. Actually, these logics will play a crucial role in solving the nodal analysis problems. Okay, so having the discussion about the procedure of the nodal analysis and the important basic logics, so how to apply the Ohm's law in the branches if the nodal voltages are known. Okay, so keeping all this in mind, so in the next session, so we'll try to go ahead with the problems of nodal analysis. Okay, so thank you for giving this opportunity, dear students. So try to follow this lecture series done on network analysis. Okay, so slowly you'll be getting the concepts and how to apply those concepts, okay, in all the problems of network analysis. Okay, so thank you for giving this opportunity.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.